problems we are going to be start now regarding our identities. Okay. Yesterday we have not completed any problem. We just discussed the identity. Let me go to do the problems based on that, and then we can move to the next set of things. Okay. Now the first problem. I will going to give you one problem now. If I have sin theta plus cos theta whole square equals 1 plus 2 sin theta cos theta. They're going to ask you to prove this. Okay. I will write it again here. Sin theta plus cos theta whole square equals 1 plus 2 sin theta times cos theta. Can you please tell me how to solve this problem? Any idea you have? In order to prove anything, you need to take LHS. What is the LHS? Left hand side of the equation, sin theta plus cos theta whole square. Is it? So what is the expansion of a plus b whole square?
So sine theta squared plus cosine theta squared.
Very good. And also it will be not a multiple, no. A square sin square theta plus cos square theta plus 2 sin theta times cos theta. Is it clear why we are going to write this one? Is this your doubt?
Yeah, I doubt that.
You see, this is the formula. Algebraic expression a plus b whole square is equal to a square plus b square plus 2ab. Why I get 2ab? Because it indicates a plus b whole square means it is not a square plus b square only. You have to multiply a plus b times a plus b. That is the indication. A plus b whole square indicates. Normal multiplication, if you do, what you have to do? A times a you have to do, and then a times b you have to do, right? A times a is a square. Is it?
I don't even know what you're talking. I'm not even. Sure.
Any doubt with this, or this part you understood?
If you don't understand, tell me you don't understand.
I don't understand.
Yes, I will going to reply back. My thing is, this is the one. A plus b whole square. Can you please tell me the result of this a plus b whole square?
A squared plus b squared plus 2ab.
Very good. If you know this, the one what I write, that also you can able to understand. Why? Because sin theta plus cos theta whole square are written before. Okay. In the place of a, you compare this one. In the place of a, you have sin theta. In the place of b, you have cos theta. Whole square, as it is present. So you need to write it sin square theta plus cos square theta, as it is like a square plus b square, and then plus 2 sin theta times cos theta. Is it? Are you clear now?
Yes.
You are just comparing this equation with this algebraic identity. Okay. Now, according to our identity, sin square theta plus cos square theta is leads to you 1. Right?
Yes.
This is the required RHS, what I given before. 2 sine theta times cos theta remain as it is. We can't reduce further. So sine theta plus cos theta whole square is equal to 1 plus 2 sine theta cos theta. Are you clear about this now?
Yes.
Like this problems we're going to get to solve. By using the identity, we need to reduce the things. They will not going to give you the direct problems. You need to use this identity inside the problem. Then only you can going to arrive the result. All the competitive exams what you're going to have in the SAT 1, SAT 2 or even CAT, at that time even ACT programs, at that scenarios, all the things basic will be this trigonometry. You want to learn the calculus, basic foundation is trigonometry. So make sure if any small doubt if you have, please make it, don't hesitate to ask. Okay.
Alright.
Next thing is how to write the sign. If it is sine of minus theta, we're going to write it as minus sine theta. This theta will be going to call it as angle. The one which is outside the function, we're going to call it as magnitude. Yesterday I explained you amplitude, period, frequency and also phase shift. Is it so?
Yes.
In all that function, what I am going to write a sine of something. This sine theta is called a function. For that, how much length that wave is present, that is represented by amplitude, that will be a number, just a constant which must be outside the function, not inside the function. Clear?
Yes.
Amplitude is one which is always outside the function, that is times with the function, and angle or phase will be going to be present inside the function. This theta represents the inside the function. If you are going to start your wave, sine wave or cos wave, any trigonometric wave, if the theta value, if it is negative, for the sine you're going to get amplitude also negative, means this is your mean position. You are starting your wave like this. It means this is minus 1, right? This is plus 1. In the y-axis, if you consider, the downwards will be a negative values, upwards will be a positive values. It is the indication starting point is negative. Is that clear?
Yes.
And one more thing you need to be noted down here is sine function is going to call odd function. Sine function is called odd function. Cos function is known as even function. Do you have any idea about odd function and even function?
No.
The value, what I told, this all trigonometric values are periodic. Means going to repeat at equal intervals of time. If it is a even function, even though if you're going to get negative, that is converted into positive. It will be going to get the amplitude or starting point with 0, 2, 4, 6, 8 like that. Okay. The maxima and minima will be going to reach it at even values. Gives you the even result. When you go for sine, it will gives you 1, 3, 5, 7. Odd values it will return. Understood?
Yes.
Anything to the power odd value will gives you negative only. Negative power, negative 1 to the power odd value. Odd value can be represented as 2n plus 1. It going to return you the value minus 1. If it is a even number, whatever may be the n is a number, you need to substitute. Minus 1 to the power 2n always return you plus 1. Understood?
Yes.
Yes. Need to remember here is this one is going to be represented as odd function. This is even function. Sine of minus angle of inclination. Instead of theta, I am tell it as angle of inclination, because sine of minus alpha can also you can write. That will be just an angle. Okay, need not to be worry about theta, alpha, beta, whatever it may be, even a, b, c, whatever you can consider, that all represent inside the function is just an angle. Okay. Sine of minus angle will going to leads you negative amplitude with positive angle. Do you clear what I am telling? Example
Yes.
is sine of minus 30 if I going to write. How you can plot this in the graph? Circular plane, if I am going to write minus 30 means where you going to put? Just simple, this is 0 degree, right? If I am going to plot here, this is plus 30. Is it right?
Yeah.
If I am going from
Yes.
the backward, if I my journey start, it means 360 minus 30. This will be going to be 330, right?
Yes.
That's why we going to minus 30. It is the indication we have to travel from the back end. So since the waves are periodic, we're going to make the amplitude itself into the next cycle. When we're going to write how in the Cartesian plane like this, right? The value what you're going to have here, it will be same here also. If you're going to represent, but amplitude value is negative. Is it clear? If I'm start the wave in this way, you're going to get same amplitude but negative value, negative amplitude. Direction is different. So we are multiplied with negative. Understood?
Yes.
Is I am clear with this or can I tell you again?
No, you clear.
Cleared. Good. So the next concept you need to remember here is double angle identities. Double angle identities, before going to that, you must know some of the derivations. Are you come across in your college or school? Sine of a
Yes,
plus
sir.
b,
Like a
sine a
tan.
cos b, cos a sine b.
Nothing.
Not come across? Can I help you with this? How to derive?
Yes, please.
Okay. See, these are the we going to call adding of angles. For example, you're going to consider one of the plane like this. Okay. Consider one point is present here. That point, let it be P with an coordinates x comma y. Okay. And draw a perpendicular to it. If you draw a perpendicular, now we are going to get it as a right angle triangle. Any perpendicular drawn to the x-axis always going to intercept the x-axis with 90 degree. Is it true? You
Yes.
just call this angle as A.
Okay.
Are you comfortable?
Yes.
And then you just move that point to the some more distance. Let that position be Q. That will be again some value x comma y or else x1 comma y1. another position. From that again you put a one vertical line and you call this angle is going to be B. Understood?
Understood.
So what is the total angle? A plus B, right?
Uh, A plus B.
So that can be going to represent with respect to sine. This derivation is a too lengthier one. You just need to remember this derivation like this. If you're going to get sine of A plus B means you're going to get it as sine A cos B. This is called sum of angle become product of angle. Cos of cos A cos B. Sorry, cos A sine B. This is the result you need to remember. Three results again need to remember. Cos of A plus B, if I'm going to derive in that by using the trigonometric definitions, we're going to get cos A cos B minus sin A sin B. Okay? And tan of A plus B, if you're going to do, that will be different. Okay, tan of A plus B means sine of A plus B divided by cos of A plus B. Do you understood this? Just need to be remember sine of A plus B will be equal to sine A cos B plus cos A sin B, and cos of A plus B is equal to cos A cos B minus sin A sin B. Is this clear? I will,
Yes.
if you need explanation and derivation, I can do it more. If you are clear, you just note this point, then I can move to the next parts. Do
I
you
am
need
clear.
more explanation for this?
Yeah.
Okay. Don't feel hesitate to ask. If you have something to doubt, something to ask, please ask. Okay? This is called standard result. I will going to give you that derived part itself. Give me a second. This we called compound angles. We're going to be added something, right? So it is called compound angle.
Okay.
Are you seeing now the compound angle?
I see it.
Yeah. So they are going to give you more problem only. First I need to explain you the derivation and then I will take you to the problems. See, this is the one I am trying to explain you. That is the one I written before. Sine of A plus B equals sine A cos B plus cos A sin B. Today's our discussion is about compound angle. So this is for your reference. Sine of A minus B is equal to sine A cos B minus cos A sin B. This all thing we can going to derive. Okay, but finally we need to remember this result is enough for our competitive exam. For our understanding sake, we can derive also. Okay. See how to derive this. You need to make one unit circle to derive this. From that we need to move the point with respect to perpendicularity. You can see here they are using here alpha and beta. The figure what you are seeing, the previously what I drawn, is it the same way?
Say it again.
The what is the figure you're going to be seen here? That is one look like what I am taken initially, this as P and this as Q, right?
So what are you asking?
I am asking about
Yes.
while deriving the relation of sine of A plus B, I am showing you one figure, that is this diagram.
Yes.
The same one here they are showing you how to derive it. We are seeing how to derive this compound angle formulas what I mentioned before. In trigonometric identities while doing, I am mentioning these formulas, right? Sine of A plus B means sin A cos B plus cos A sin B. Cos of A plus B means cos A cos B minus sin A sin B. Tan of A plus B means this part. These are the three things I wrote it before. I think you are saw that, right?
Yes.
Only if these three, if you remember all other trigonometric identities you can derive. You see remaining how many are there? All the things you can do it with these three. These three are important. Basic compound
Okay.
angles. That one I am showing you how to derive it now. Okay?
Yes.
See, in order to derive that, you first know the important thing is what to be done here. In order to derive this can be done only with respect to construction. Geometrical constructions we need to make in order to derive this. Okay?
Okay.
Excuse me. What all the constructions are made it here? First, they are consider origin and they are first present at the x-axis and then they start moving. Then that position is they call it as z and then again they start moving. That position they call it as y. First you need to observe this part. This one. X, Z, Y. Understood? First it is at the origin initially and then it start moving and then it will be reached to this position. Whenever it is at zero position, no angle. Angle made by this OX to OZ is we going to call that one as alpha minus beta because we going to consider the angle made by OY to OX or else YOX is alpha. Do you agree with this?
Yes.
And can you tell me by seeing this plot what is the angle made by YOZ?
B.
Beta.
Angle B.
Beta. We are going to call it as beta. Okay.
Okay.
So
Okay.
once we are going to call this as alpha, this as beta, obviously the remaining angle is ZOX is alpha minus beta. Is it
Yes.
clear?
Yes, it is.
This is the diagram first you need to understand. Afterwards we do some constructions. we are considering one point called A on OZ line, and we consider one point C on OY plane, and then we going to draw a perpendicular to the x-axis in order to construct the right angle triangle. Because if we have the right angle triangle, then only we going to get all the trigonometric ratios are going to be valid. If no right angle triangle, we don't going to possible to apply the trigonometric ratios. So in order to make one trigonometric ratios to apply, we going to write perpendicular from the point whichever we going to be considered. Is it clear?
Yes.
And then again one more perpendicular is going to be drawn from point A to point C. Okay? See, this
Okay.
point C and point A is perpendicular, and we going to extend this and extend this. They're going to get one more join. Is it clear? This figure you understood, then we can go to the derivation. I am clear with this?
You're clear.
Yeah. The most importantly, by seeing that particular figure, we're going to derive this. When you consider here the right angle triangle is alpha minus beta. I'm going to make it with some enlarge this part. In this figure, this part of the triangle I am going to be consider. What is the angle of that part?
Uh, hang on. It's
Alpha minus
minus.
beta, right?
Yes. Yes.
Because this complete will be alpha, this part is beta, and this part must be alpha minus beta. Is it true?
It's true.
This one we going to be consider for our analysis. What is the definition you know about cos theta, cos alpha, whatever may be, cos function?
Oh, like cosine is adjacent over
Very good.
hypotenuse.
Yes, that one. Adjacent by hypotenuse. Here adjacent means base, right? For this triangle, what the triangle we are considered is this one. In this region, what you going to see in this triangle, what is the adjacent region?
Um.
OB,
Uh.
this length.
OB.
Yes, OB is the adjacent. What is the hypotenuse? OA.
OA.
That one only they are written here. Cos alpha minus beta is OB minus OA. OB by OA. Is it clear?
Yes.
So OB can be written it as OD plus DB. This distance is the combination of these two, no? This is represented as O, this is represented as D, this is represented as B. So can we split this as OB as OD plus,
DB.
yes,
Yes.
DB.
You
That
could.
one they are given here. Then we have a common denominator, we can split that. OD by OA plus DB by DA. Is it?
Yes.
Is this part clear?
Yes.
Okay. Now we need to going to put the remaining dB equal to CE. Why we are going to put? Because you see dB value and CE value, they are parallel, right?
Yes.
So we can replace dB with CE. Clear?
Yes.
Okay. Now we need to represent with some of the angle we need to be going to taken place. So in order to do that, we are going to put OC multiply to this and divide to this. If I have 5 with me, if I am going to multiply 6 to it and divide 6 to it, the value of 5 remains same, right?
Yes.
This is called rearrangement in order to get the result. Okay, I have OD by OA, so I'm introducing this OC times and also divide that OC also. Rearranging the terms. OD by OA can be rearranged for the convenience of deriving as OC times OC divided by OA. OD by OC times OC by OA means these two cancel. This result remains same. But we need to rearrange like that. Is it clear?
Yes.
And even CE by OA can be rewritten as CE by AC times AC by OA.
Yes.
So when you are going to see, we need to write it back in the form of ratios. Here we have ratios. From ratios to trigonometric values, we need to convert it back. How to convert it back? By seeing the triangles. What this OD represent, what this OC represent. Let us see the diagram again. What is OD and OC? In OD and OC, which triangle represent? This triangle now. This
Yes.
alpha triangle going to be represented, right? OD and
Yes.
OC, that is adjacent and hypotenuse. OD is the adjacent, OC is the hypotenuse. So can I put back it as cos beta? Instead of OD and OC, can I replace this as cos beta?
Yes.
Sorry, that must be cos alpha, right? Just check it
Oh.
out. This is alpha, not beta. This triangle is represent alpha, right? From year to year.
Okay. Yeah.
Yeah. So we are going to consider OD by OC as cos alpha. Next part is OC by OA. Just identify where that OC by OA is present. This is OC. Where is OA? This part, right?
Yes.
So the triangle we are going to be consider here is this one. This triangle, is it? Is it clear?
Yes.
So here you can easily guess OC is the adjacent side, OA is the hypotenuse. So you can replace OC by OA as cos beta. Are you clear about this? This is
Yes.
cos alpha, this is cos beta. In the same way, if you go for CE and AC analysis, you're going to get it as sin beta, and AC and OA analysis, you're going to get sin alpha. Only with this triangle, if you consider and then go on analyzing, you're going to get the results. Understood?
Understood.
This is the way we're going to prove all the result. What the compound angles we have, around 10 to 12 compound angles, all those angles can be derived by using that triangle construction with the help of movement of the locus. Locus means point movement. Clear?
Clear.
Okay. So I advise you to remember these results. I will give you memory tip. How to remember the things. Just concentrate for 2 minutes without having any distractions. Okay? Before, if you know this, you may feel it if it is difficult to remember all those things at a time. I will give you one memory tip. Based on that, you just remember all the things. Okay?
Yes.
Anything if you have with respect to sign inside, a plus b, a minus b, alpha plus b, whatever be the two angles with respect to sign, if you have, you need to do just sine and cos multiple first. Sine times cos, what the angle they are given, that angle you have to write. First thing, that is the first term. And next put plus and just change the angle order. If you write it first sine A, here you write it cos A and then sine B. Do you understood the trick what I am telling?
Yes.
You have to write sine and sine cos, cos sine, or else sine cos itself, but angle need to be changed. If you firstly, if you going to consider it as sin A cos B, second time you have to consider it as cos A sin B. Understood?
Believe
This
so.
angle is going to be replaced. Next is, if it is two terms, you just tell me what is sine of alpha plus beta now. By
You
using,
mean
in place
sine?
of A I put it alpha, in place of B I put it as beta.
So alpha beta plus beta alpha.
Very good. Sine alpha cos beta plus cos beta times sine beta, beta not alpha. I am just changing these parameters with respect to sine and cos. Whenever sine of multiple angle is going to become in the problem, you need to write sine cos plus cos sine. That you need to remember. Sine cos plus cos sine. If you write sine cos plus sine cos, not a difference, because a times b is equal to b times a. But angle you need to be exchange alternatively. That is the one you need to remember with respect to sine multiple angles. Understood?
Yes.
This is added. If I am going to subtract something, what I have to do? I just replace this addition symbol with negative symbol. You can see here sine of a minus b, they are written it as sine a cos b minus cos a sine b. Is it? You just
Yes.
compare these two results. Then you will be feeling very easy to memorize. You can remember the sine compound angles. Is it clear about that topic?
It's clear about that topic.
Yes. Now, how to remember cos multiple angles? In sine multiple angle, what you did, sine times cos plus cos times sine, you are written. Sine times cos, again minus cos times sine. Angle you are just swapping. In the cos, if it is come, you need to write cos times cos, sine times sine, two term like this. I will tell you how to take the sines. Just remember, don't even remember this angles also at this scenario. Don't remember the derivation also, not required. You just remember if cos multiple angle come, cos times cos minus sine times sine. Is it clear?
Yes.
After, you just put one time A, one time B. Cos A times cos B, sin A times sin B. If you have in the cos inside addition, when you're going to convert, it become negative. But it is not in the case of sine. If you have positive here, here also you have positive. but in cos it is different because it's a even function. So cos A times cos B minus sin A times sin B.
Sure.
Yes. Then cos A minus B. Here this become plus. Here whatever is there, the same thing will come, but here it get reverse. Always like that. Because cos of minus angle will gives you cos of plus angle only. This is the basic thing. Because cos is a even function. Clear? So what? We're going to get this sign changes. Are you clear about these four formulas now?
Yes.
If you have any doubt, please feel free to ask.
I don't have any doubt.
Very good. If you know that, I will come to this too, how to going to get that part. Before that, let me go for the tan part. In order to
Okay.
know the tan part, you should know what is tan A, how I can going to be written it as sin A by cos A. Tan can be represented by sin by cos. How it may be your question? It is very simple. What is the sine definition? Sine trigonometric ratio definition? Opposite
Opposite over.
by hypotenuse. Cos definition? Adjacent by hypotenuse. Right? What happened now? This hypotenuse cancel. You will be available with opposite by adjacent. Is this the definition of tan? Opposite by adjacent is the definition of tan, right?
Yes.
So you're going to be represent that sin by cos as tan. Clear about that?
Yes.
Okay. Now the thing is how to derive the relation for with respect to compound angle for the tan. So I am starting by deriving this part by using a concept of the primary relation what we have sin of a plus b by cos of a plus b. Can I write like this? As it I showed you before, tan a can be written it as sin a by cos a, right? Instead of a, I have here a plus b, so I am written it as sin of a plus b by cos of a plus b. Are you clear this step or shall I show you again?
Can you show me again?
Okay. See, the previously what I showed you is tan A equals sin A by cos A. Why I going to write like this? Because this is you consider as LHS, right? This is RHS. In order to prove any relation means you need to prove LHS equal to RHS. Is it? Then we going to call this as a proper equation or proper relation.
Equal on right hand side.
Is
Okay.
that? Are you clear about that?
Yes.
So what is the definition of tan A?
I think the tan is opposite over adjacent.
Very good. Opposite by adjacent is the definition of tan. That is your LHS. What about the RHS will going to get? That can be done by sin A by cos A, right? Sin A definition is opposite by
Hi.
hypotenuse. Here this is adjacent by hypotenuse, right? Is this part clear? Whenever you going to take the denominator term to numerator, that time you're going to be get the things reversed. Hypotenuse by adjacent you're going to get. Is it so? This
Yes.
denominator goes, so hypotenuse cancel. You're going to get opposite by adjacent. That is equal to this LHS. This LHS equal to RHS. Is it clear?
Yes.
That way we can going to use tan A as sin A by cos A. In the same way, tan of A plus B can be rewritten as sin of A plus B divided by cos of A plus B. Okay, is it clear?
Now it's clear.
Now I am going to use the previous result. What is sin of A plus B? Sin A cos B plus cos A sin B. Is it true? Whole divided by cos A cos B minus cos A cos B minus sin A sin B. Is this part understood?
Yes, it's understood.
Now the thing is, I want all the terms in the form of tan because I am writing here the compound angle for tan. So rearrangement I have to do. How to do? By going to divide the numerator as well as denominator by cos A cos B. Do you understood? For
Yes.
example, I have 2 by 5. I am going to be rewritten it as 2 divided by 4 whole divided again 5 divided by 4. Is your equation, is the value of 2 by 5 remain same or different?
Value is the same.
Same. In the same way, this is the numerator. For this, I am going to divide it by cos A cos B and for both, as well as in the denominator part also with cos A cos B. Do you clear about this, what I am talking?
Yes.
So at that scenario, this cos A cos B is belong to this term as well as to this term. And this cos A cos B belongs to this term as well as to this term. At that scenario, sin A by cos A can be going to be put it as tan A. And cos B divided by cos B cancel. Here sin B by cos B will come as tan B whole divided by this term is going to be divided by this cos A cos B, but this term if it is going to consider, that gives you tan A tan B. Understood? You need not to
Can you
remember.
explain it one more time?
Yes, please. I will going to explain you one more time. Not an issue. Just observe, tan of A plus B can be rewritten it as sin of A plus B by cos of A plus B. This part I think you don't have any doubt. Is it? Do you
No,
have
there's
any?
no doubt.
Yes. And then I have to substitute it sin of A plus B as sin A times cos B plus cos A times sin B. Is it true?
It is true.
Then what about cos A plus cos B? Minus sin A sin B
Yes.
Now the thing is, I'm going to divide whole term with respect to cos A cos B because I need only the relations in terms of tan.
Tan.
So I will going to divide the whole thing by cos A cos B. So it is the indication that cos A cos B come to both sin A cos B divided by cos A cos B plus cos A sin B sin B. This is again cos A cos B. I make it that cos A cos B available to each term. Okay, this is the numerator term only I am writing here, and then
Yes.
cos A cos B by cos A cos B minus sin A sin B divided by cos A cos B. Do you understood how I separated the terms? Denominator
Yes.
terms I separated like this. So cos B cancel. Here cos A cancel. Here cos A cos B cancel. Here we don't have any to
Yes.
cancel. What is the remaining? Sin A cos A, right? Sin A by cos A. Is
Yes.
it?
Yes.
Okay. What's the relation we have for sin by cos? Tan. That we have started, right?
Tan.
So I'm going to return tan A. In place of sin A by cos A, I can rewritten that one as tan A. Clear?
Yes.
And sin B
Yes.
cos B can be rewritten it as tan B. Is it so? The plus remain as it is. Here everything is cancelled, so 1 will be coming. Here sin A sin B divided by, sin A sin B divided by cos A cos B means I can replace the sin A cos A as tan A, sin B cos B as tan B. Is it true?
It is true.
Good. That only they are written. Tan A plus tan B divided by 1 minus tan A tan B. Okay? So how to remember tan compound angles means if you have tan A plus B, you have to return tan A plus tan B. Tan plus tan with different angles what you have in the multiple. And then 1, if you have plus, you have to make it minus. Tan A, tan B. Okay? If it is A minus B, if you're going to have at that scenario, you need to change the sign in the numerator with tan A minus tan B divided by 1 plus tan A tan B.
Very good.
This sign will be in the numerator as it is we going to get. But in the denominator it reverse. Is it clear?
Yes.
So I felt you can going to be understand up to this 6 result without any doubt, right?
Fine. Yeah.
So next thing is if I going to use the basic identity sin of a plus b into sin of a minus b, we going to get the remaining part like this. We going to derive those things in our next class when we have it in the when we resume to the next session. Okay, it will also be, you can remember also, if you remember this part with multiple, we're going to get this one different result. While doing the problem also we can going to derive this. Understood?
Understood.
Do you have any doubt in today's class discussion?
No.
Please ask if you have any doubt.
I do not have any doubt.
Very good. So I just send you the links, the what all things I discussed till now. It will be a good thing you go through it again, and problems
Yes.
also available in that. If you go through it once, it will be more clear, or else we will go to do the problems in our next session. Next session is completely on problems. We don't left with any derivation still. We are completed all the derivation, all the results which are going to be coming in the trigonometry. If anything we going to derive, that can be done with represented with compound angles and basic trigonometric ratios with identities. If you are comfortable with compound angles, basic trigonometric ratios and identities, anything you can be learned in trigonometry as well as differentiation, integration, wherever you go with calculus, these three are the building blocks for your any competitive exams. Is it clear?
Yes, sir.
Yes, please make some work on that. Before to next class, I will going to share you the login credentials of in order to see your recordings. Okay,
Okay.
I will going to give you that login credential through your email.